Hello everyone. In this session, we are going to discuss one topic in the course Elements of Aeronautics. The topic is aircraft engines. Myself K. Manoj Kumar, Assistant Professor, Department of Aeronautical Engineering, Hindustan College of Engineering and Technology. Engine categories. Engine is classified into two types. The one is reciprocating engine, which contains piston, which is classified into two types depend upon the fuel used. First one is gasoline powered, second one is diesel powered. Nowadays we are not preferring diesel engines, we are only preferring gasoline powered engines. The second classification is turbine engine. Okay, the basic classifications are turbojet, turbofan, turboprop, and afterburning turbojet. Other than this, we have a turbo shaft engine also that we are using in helicopter. Turbojet we are using in a fighter and bomber aircraft. Turbofan we are preferring for a passenger aircraft, and turboprop we are preferring for passenger as well as cargo aircraft. After burning turbojet, we are especially preferring for very high speed aircraft. Those are fighter aircrafts. Next one, engine operation. That means operation of reciprocating engine. The four basic operations are: the first one is intake stroke. Here piston moves down, inlet valve opens, the exhaust valve closed, fuel air mixture comes into the engine. Second one, compression. Piston moves up, both the valves are closed, the fuel air mixture will be compressed. Third one, both the valves, or third one is ignition stroke or power stroke, where we have the spark where both the valves are closed. When the spark appears, the fuel air mixture burns and try to expand, which pushes the piston downward direction. The last one is exhaust stroke, where piston moves up, exhaust valve open, and burned fuel air mixture will goes out of the engine. This process goes on. Next one is the turbojet engine, which is the simplest form of engine. Here we have an intake, compression, power, and exhaust. That means we have airflow inside. It will be compressed in the compressor, burned in the combustion chamber, and goes through the nozzle. Intake, compression, power, and exhaust. You see here means turbojet engine is a reaction engine which substantially increase the thrust can be obtained by employing an afterburner. That means afterburning turbojet. You see here means turbojet air fuel mixture comes here through inlet. It compressed in the compressor, and then the compressed air goes to the combustion chamber where fuel added and compressed fuel air mixture burned there and expand. In the expanding process, it will rotate the turbine. Turbine and compressor are connected through a shaft. That means when turbine rotates, compressors also rotate. Due to this movement, turbine will rotate the compressor. It will suck more air into the engine. Okay, after rotating the turbine, that means done some work in the turbine, the fuel air mixture expands in the nozzle. That's how we get thrust in this engine. This is the example for turbojet engine. It's a turbofan engine. It's mostly used in commercial aircraft and some military aircraft. Here, if you see here means the incoming airflow is split into two sections. One goes through the engine, other bypass through the engine. Depend upon the ratio only we will get more thrust. And this is the more efficient engine. That's why we prefer this for a passenger aircraft. If you see here means all the composition are same like a turbojet engine, but here we have one fan in front of it. A partial airflow goes through the engine, the remaining will bypass through the engine. Depend upon the bypass ratio, the thrust of the turbofan engine depends. The main objective of the bypass system is to increase the thrust without increasing the fuel consumption. That's what this is the most efficient engine. So a few turbofan engines. Next is turboprop. Here the only difference from a turbofan engine is instead of a turbofan we have a propeller in front of it, compressor. Here that means the turbine rotates the propeller. Here also the thrust is mainly depend upon the air that pulled by the propeller. Due to the presence of propeller, it is used by the some of the commercial aircraft and some of the low speed aircraft. If you see the turboprop engine means, okay, here we have the same inlet compressor, combustion chamber and turbine nozzle. But here in front it have the propeller. When propeller rotates, the air goes, it will pull the mass of air behind of it. That's what we will get thrust in this engine. These are some examples of turboprop engine. And the last one is the afterburning turbojet. Most military fighter aircraft use afterburners. That means the engines are limited to temperature. That means we have a turbine blades. If the temperature increase in the combustion chamber means turbine blades will be affected. So here in the afterburning turbojet, what we do is we will burn the fuel after the turbine. That means here if you see here means inlet, compressor and combustion chamber and turbine. Here the normal engine operation will happen. After that we have the afterburner. That means what we will do here is we will inject fuel there again. With the already burned gas we inject fuel and we burned it again. That means here we will get extra thrust. After that it will expand in the nozzle. So by having this turbojet, the engine overall thrust will be increased by from 10 to 30%. These are all the basic engines. Thank you.